So what this is going to demonstrate is the use of the AFG31052 arbitrary function generator from Tektronix to test out some current clamps. I've got the function generator here on the right, and as I pan across I have a current clamp table here. This is a number of turns that will increase the current being driven into these instruments. At the back behind, that you can't really see too well, also a little echo. Yeah, so at the back behind there, that's just a current amplifier board, and that's a manual board, so I will be controlling the amplifier from the output of the function generator. And then just as a check, I've got over here the Fluke 88468 that's wired in series with the output of the amplifier into the coil. So then I just need to times the current being displayed on this by the turns ratio, which I'll be using the 50 turn coil, and that will give me the current that should be being displayed on the clamp meters. The two clamp meters, these are the little Hioki clamp meters, quite a basic one, but nice small ammeters to have in your tool bag with you in case you need them. They don't take up too much room. They come with a little wallet, and this particular one does have a flex probe that goes in there as well, but not much functionality to them. And this particular one is a averaging one, and this isn't true RMS one. I've reset things a little bit so that you can see each of the displays in turn, hopefully. And at the moment I'm on a standard sine wave, 50 Hz. Okay, so it's about half an amp on the Fluke there, so I should have around about 25 amps coming out of this 50 turn coil. Okay, so turn him on and position him in there, hit the hold button. So that's displaying there 25.68 amps, which is about matches that 0.5 amps coming out there. So obviously what I can do now with having a function generator is I can up the frequency. So if I up him to 200 Hz, I will need to change my voltage, because as you can see there, the current is 0.382 going into it. So because I've changed the frequency, the impedance of the coil adapter has changed, it's gone up, therefore I need to get more out of the amplifier to get 0.5 amps, and we'll wind him up. So 0.503 there, and again we've got 25.22 amps, so fairly comparable. This instrument should read up to 1 kilohertz without too much of an issue. So we'll go up to 1 kilohertz. So you see it's on 1 kilohertz, and you can see my current has dropped down to 0.148 now. Okay, so 342 millivolts needs to come in now. And if you look on my, I'm showing 0.50035 amps on the Fluke. And so look at the clamp's displaying 22.33 amps, so you can see it's starting to drop off a little bit. And if I take this up to, let's go up to 1.25 kilohertz. Okay, there's 0.5001 amps in there. And let's have a look at our clamp. So our clamp's now displaying 21.05 amps, so you can see the response has gone down, and I would imagine these will be both the same. Try him as well. Okay, so so the true RMS one has a bit better response, 24.49 amps on there. Let's go up to, well, if you can do some more, then we'll go up to 1.5 kilohertz. Okay, 0.5002 again. So we'll go back to our This is our averaging meter, 19.81 amps. Let's see, 19.81 amps, so you can see it's starting to drop off even more. And let's go for our RMS one. Still 24.02, also dropped a little bit. The light, where's the light? 24.02, dropped a little bit, but nowhere near as bad as the averaging instrument. So that's one of the values of true RMS over averaging, that you can get that slightly better performance as the frequency changes. So what we'll do now, it's another advantage with this kind of a setup, is to take him back all the way down there. We'll take him down to 50 Hertz. And what I've got loaded on the USB stick is an arbitrary waveform. So this is actually a magnetising current from a transformer, and you can see it's all misshapen. And again, it's something else that you can use to test the performance of your clamps to see how they respond. Down again there, so we're on 50 Hertz. So we're on 0.502, putting around on there, on 0.50. Yeah, flaying about a little bit. On here, we'll see what the current clamp measures. And we'll see what the other one measures. So 25.2 against 24.96. We see those. So true RMS on the left there, averaging on the right. We'll take him up a little bit more. Okay, so we've gone up to 212 millivolts there. We're now reading an amp on our fluke, so we should be somewhere near 50 amps on our current clamp table. Let's go there. Same again. So we've got 50 points, sort of light on. 50.07 and 49.2. So virtually the same. Let's see if we can get 1.5 amps out. That's the only problem with a manual. Yeah, so 1.5 amps. Let's see what we get. Bounce around a little bit, 1.49, 1.5 there. And we'll do the same again with you. So we've got 75.5, 74.5 amps. So fairly close. Yeah, but it gives you an idea of what you can do with arbitrary waveform generator and with current clamp table. I'm able to test both frequency response of clamp meters and also how they respond to different waveforms, whatever I've managed to capture, and can play back through the function generator. But that's all for this video. Hopefully that's been helpful to some people. Thanks for watching, and I'll see you again in the next video.